Welcome back to another training video using the UK Electrical Simulator. In this new video series, we're going to explore the off-grid electrical mode. This is a separate training area from the domestic installation section, and it includes the main components needed to build and test a complete off-grid power system. In this first video, we won't go too deeply into every component. We'll cover each one properly in future videos. For now, the aim is to build a simple overview system and show how the main parts work together. On the workspace, we have a range of off-grid components, including a solar panel, a solar charge controller, and a 48-volt battery bank. The solar panel produces DC power from sunlight. The charge controller manages how that power is delivered to the batteries and makes sure the charging process is controlled correctly. The batteries then store that energy so it can be used later. We also have a second renewable source, a wind turbine with its own wind charge controller and battery bank. This helps show how more than one charging source can work together in an off-grid system. Next, we have an inverter charger. This is used to convert the battery's 48-volt DC power into 230-volt AC, so we can supply normal AC loads through a small consumer unit and then onto a 1.5 kilowatt load. And finally, we have a generator. The generator does not feed into the solar charge controller. Instead, it can supply the AC input side of the inverter charger. This allows the inverter charger to either pass AC power through to the load, charge the batteries, or support the system when solar and wind generation are not enough. So by the end of this introduction, you'll have a clear picture of the basic off-grid layout: the generation, charge control, battery storage, inverter conversion, AC distribution, and backup generation. Let's start wiring the system and see how each part connects together. First, wire the solar panel to the solar charge controller. Positive to positive, negative to negative, and earth to earth. The simulator will automatically choose the wire type and color, so we don't need to worry about that at this stage. Next, wire the wind turbine to the wind charge controller in a similar way. You'll notice a percentage value shown on both the solar panel and the wind turbine. This represents the available power based on the current sun and wind settings. These values can be adjusted using the sliders in the left-hand component panel. Now wire the batteries, one for each charging system. Once everything is connected, submit the design changes and you'll see both batteries begin to charge. One from the solar panel through the solar charge controller and the other from the wind turbine through the wind charge controller. Next, wire both batteries into the same DC input side of the inverter charger, making sure the polarity is correct. Positive to positive and negative to negative. There are no earth terminals on the batteries. In a real-world installation, we would normally include suitable DC fuses, isolators, or DC breakers between the batteries and the inverter. That protection is not shown here yet, but it is something we plan to add in a future release. Now wire the generator to the AC input terminals of the inverter charger, line to line, neutral to neutral, and earth to earth. The generator provides a backup AC supply, which the inverter charger can use for pass-through power or battery charging when solar and wind generation are not enough. Next, wire the AC output of the inverter charger to the line and neutral input terminals of the mini consumer unit. Also wire the earth terminals. Finally, wire the consumer unit to the 1.5 kilowatt socket load using the 16 amp breaker. Also add a ground spike and connect it to the earth terminal on the consumer unit. We now have a working end-to-end solar and wind off-grid system. We can add clamp meters at different points in the circuit. We can use these to see the current flow at each stage. When ready, energize the consumer unit and switch on the load to see the system in action. At this point, the 1.5 kilowatt load is drawing energy from the batteries through the inverter. If the batteries begin to drain, we can either increase the available sun and wind input or switch on the generator. The generator can then support the AC load and allow the inverter charger to recharge the batteries. This gives us a simple overview of how an off-grid system works. Renewable generation charges the batteries, the inverter converts stored DC energy into usable AC power, and the generator provides backup support when the renewable input is not enough. I hope you've enjoyed this introduction to an off-grid electrical system. In the next videos, we'll slow things down and look at each part in more detail. Please like, subscribe, and leave a comment below.